Now we had a first look at indexes. Now let's again look at a single document in our contacts database. And we created an index for the age here. Now we dropped it in the last lecture, but previously we did. Now, of course, you cannot just create indexes on fields that have a number. You can also create indexes on fields that have some text. And that makes a lot of sense because, well, text is also something you regularly search for, and it can also perfectly be sorted. Booleans, on the other hand, are something that don't make too much sense because since you only got two kinds of values, true or false, chances are that an index will not speed up your queries too much. Now, let's create a second index, or actually a first one because I dropped one. And let's now use a text index. And for that, I'll try creating an index on the gender, male here. I'll do this on my collection with create index. And I'll look for the gender field to be sorted ascendingly. Now, of course, one problem you might already think of is that for gender, just like for a Boolean, we typically only have two values. And indeed, if I do run an explain command with execution stats on my contacts, and I try to find all contacts where gender is equal to male, I should get back a lot of keys, right? I should get back like half the documents because this random collection of persons is pretty evenly distributed. And indeed, of my 5,000 documents, 2,400 are male. So this again is probably an example for an index that doesn't make too much sense or that doesn't really speed up our queries because we fetch the majority or a large chunk of our collection every time. Still, we use the index here, of course. This also tells us something about the winning plans and rejected plans, by the way. You see that MongoDB didn't seem to consider a collection scan because we have no rejected plans. So for the rejected plans, it also looks at other indexes, but not really at the collection scan as an alternative. So this index alone doesn't make too much sense. But there is another kind of index we can use. Because let's say we want to find all persons who are older than 30 and male, or older than 40 and male. And for this we can create a so-called compound index. Now let me drop this index first of all. db contacts drop index. And I'll drop my gender ascending index here. And let's create a new one here. And this index will not just have the gender, but actually as a first key, let's say I want to look for DOBH, and that sort this in ascending order too. Now the order of these two fields here does matter, because a compound index simply is an index with more than one field. Like here, we got two fields. And this will essentially store one index where each entry in the index is now not a single value, but two combined values. So it does not create two indexes, that's important. It creates one index, but one index where every element is a, well, connected value. So now it will simply create pairs of ages and genders. So we'll have 30 male, 30 female, 31 male, 31 female, and so on in the index list. And the order here defines which kind of pairs MongoDB creates. Does it create, let's say, 31 male field or a male 31 or 33 field? And this will be important for your queries, as you will see. So let's create that index. Created the index successfully. And now we can utilize such a compound index with two different queries. The obvious query that takes advantage of the index is that if I explain without execution steps here, a find query where I try to find all people where the age is, let's say, 35 and all the people who are males. So I can also set gender to male. So I got two elements in my filter here, the age and the gender, and these are the two elements I also have in my index. Here, the order does not matter, by the way. If I hit enter, you see it actually did an index scan with our index name, and this name is auto-generated. It indicates that this is a compound index because the name is generated from the values that are placed in the index. So this is a compound index, and this speeds up our queries for requests that are well, going to these two fields because we have these two in an index. Another query that is sped up by that same index is if I just look for the age. If I do that, you see here, it also used an index scan. And it used that same compound index, even though I never specified the gender in this request here. But the compound index can be used from left to right, so to say. So if you have age and gender in there, and the leftmost value as you created the index was age, and then the second value was gender, then you can use this index either for all finds that look just for the age, so for the left part, or left and gender. Gender alone won't work though. So if I try to look for all males with gender male, you see that of course works, but it uses a collection scan and not an index scan because it can't look into that second value standalone. And that makes a lot of sense because if you got a couple of pairs of values in that index, 33 male, 33 male, 33 female, and so on, then you can obviously use that index if you just look for 33 because you just have to go through all the values because they are sorted by these key value pairs, and the first value of course defines the sorting for the overall index. So 33 comes before 34. The male and female parts are then also sorted, but only within their category, so only for 33, 34, 35. Of course, the male and female parts are not sorted on the overall list. Makes sense, right? Because they are grouped together with the age numbers. So therefore, you can utilize a compound index from left to right. So if you had a compound index with 3 or 4 elements, you can have up to 31, then you could also just use the first 2, the first 3, or all 4, or just the first. But you can't use the fourth one or the third one. These are some restrictions you have on compound indexes, but compound indexes in general allow you to speed up queries that use multiple values if you create a compound index on these multiple values.